Hello and welcome back. So today we are going to talk about similar shapes. Excuse me. So there are a lot of ways we can use similar shapes. We can use them in the real world when we're building models to make sure everything is to scale and stays the same. We can use it in web design whenever we're increasing or decreasing a picture size. I use it in photography when I'm cropping pictures and changing the ratios to make sure that everything is good. Um, we use it. We can use it in the wild if we want to know how tall a tree is. We can measure our shadow and have a similar shape to the shadow of the tree and get a distance that way. Or maybe some weird alien monolith showed up and you want to know how tall it is, but you don't have a tape measure, but you can see your shadow or whatever. All the different reasons that we would want to find similar shapes. Regardless, today we're not getting into the application. Today we're just asking, are they similar shapes? Okay, if something is different about them, then we're not going to be able to use all the properties. So we need to make sure that they are similar shapes first and foremost. To do this, we are going to ask two questions. Okay, we are going to ask similar shapes. Shapes are similar if, one, the measurement of the corresponding angles are congruent, and two, the ratios of the lengths of corresponding sides are proportional. This means they must have an equivalent ratio. Okay. So we're going to kind of look like we're working with fractions, but we're actually working with ratios. So let's go on ahead. On your sheets, you're going to have these boxes. And yes, I expect you to put all of the work inside the box. Okay. The first thing is we got to write the two different questions that we need to ask. The first one is, are the angles congruent? Now in math, we all know mathematicians are kind of a lazy breed. We've made words for angle. So angles, are angles congruent of same measurement? And that's what congruent means. I don't know if I said that before. Congruent means of the same measurement. So if I have an angle that's 45 degrees and an angle that's 45 degrees, it doesn't matter if they're facing the same way, the same measurement, they're congruent. Now, if I had 45 and 43, those are not congruent. They are not the same measurement. Okay? So the first test is they must have corresponding angles that are congruent. And the second is that corresponding sides must be proportional. Like I said, I want to see both of these questions written. Okay. So let's take a look. Now, remember way back when Mr. Holloway learned about triangles, he started comparing triangles, and his math teacher made him say, we're going to look at the big angle first, then the little angle, and then the angle in the middle. It's just the way I've always done it. It's the way I will always do it. So first big angle is 83. In the little triangle, what's the big angle? 83. Those are the same measurement. They are congruent. Now I'm going to look at the littlest angle, 32, 32. Those are congruent. They are the same measurement. And now my other angle, 65 and 65. So those are all congruent angles. So are the angles congruent? Yes, we can say with confidence the corresponding angles are congruent. Now, are the sides proportional? That's a little bit hard of a question to answer. We can't just say a number isn't a number and make it work. So what we're going to do is we are going to again start with our largest angle. To find corresponding sides on a triangle, the easiest way is to use the angles and go to the opposite side. So opposite 83 degrees is 24. I'm going to write the 24 up top. And now when I build the ratios, I prefer to put the big shape on top and the little shape on bottom. You don't necessarily have to put the big shape on top. You could put the little on top. What's important is that it stays the big shape on top, or it stays the little shape on top. And I'll show you a little bit more about this. I don't want to confuse you too much. And it might be easier to just consider, don't think about it, big shape on top. So the little shape opposite the 83 is 16 feet. Now let's move on to the littlest angle. Opposite 32 degrees is 15. Again, big shape on top because that's what we did on the first one. The little one, opposite 32 degrees, is 10. And then my last angle, big shape on top, opposite the 65 is 21. Opposite the 65 for the little one is 14. Okay, now these should look kind of like fractions. They are. You might be tempted to call them fractions, but they're not. They are ratios between these two triangles, ratios of the sides. Now, the easiest way to find if they are proportional is to reduce this as if it was a fraction. So what can I reduce 21 over 14 by? Well, I can reduce the top and the bottom by 7. So I'm going to write my 7 here and here. And then I'm going to say, so what times 7 is 21? 3. What times 7 is 14? 2. Okay, so I now know the top and bottom are the same proportion. It's the same multiplication that I'm doing. So those are proportional. Now I need to look at the next one. 3 times what is 15? Well, 3 times 5 is 15. 2 times what is 10? 2 times 5 is 10. Oh, look, 5 and 5. Those are proportional. Well, let's check the last side. 3 times what is 24? 3 times 8 is 24. Okay, let's check the bottom. 2 times 8. 2 times 8 is 16. Top and bottom are the same. So are all of my sides proportional? They absolutely are. And now let's go back and look at our question. So the shapes are similar if the measurement of the corresponding angles are congruent and if the ratios of the lengths of the corresponding sides are proportional. So are these similar shapes? They are similar shapes. Yes. Let's take a look at another example. Let's look at E on your worksheet, shall we? Okay, E. So we have to ask our same questions. Are the angles congruent? Are the sides proportional? Proportional. Remember, it's a math class, not a spelling class. I'm not a good speller. All right, so biggest angle and the biggest shape. Oh, you know what? Nope, I want to keep the big one on top because I don't want to confuse you. Biggest shape, biggest angle, 105, okay? Littlest shape, biggest angle, 105. Okay, those are congruent. So now smallest, 70. And the smallest in the little shape, 70. Now the next biggest one is 85 and 85. And then my last angle is 100 and wait, there's nothing here. Okay, side quest. Our side quest. How many degrees are in a quadrilateral? On the inside angles. If you add all the angles up, how many degrees are in a quadrilateral? Did you say 360? It's 360. So that means if I have 360 degrees to give, right, I'm going to subtract these. So minus 85, oops, 10, 5, so that'd be 5, 2, 5, 8, 9, 10, 11, 12, 13, 14, 15, and 275, and now I got to subtract my 70, 205, and now I got to subtract 105, 100. So I have 100 degrees left. Oh, look, it works out. So I have 100 degrees in the big one, 100 degrees in the little one. My angles are congruent. Now I need to find out if my sides are proportional. I do not have the privilege of working with opposite angles this time. So I actually have to define my lines by their angles. So I'm going to draw a line from 70 to 85 degrees. That gives me 45 feet. Again, I'm doing big shape on top, little shape on bottom. And now I've got to go again, 70 to 85. So 70 to 85 is 25 feet. Did you notice it flipped? The 70s over here, but that line is still 70 to 85 regardless. Let's keep working our way around the big triangle. 85 to 100 is 20 feet. And then we're going to go 85 to 100 degrees. So again, we're defining it by the measurements, is 12. And then we're going to go from 100 to 105 is 40. 100 to 105 is 24. And then our last side, 70 to 105 is 25. 70 to 105 is 15. Okay. And voila, we have our ratios. Let's see if they are proportionate. Again, easiest way, let's simplify this one. What can I divide 25 and 15 by? Well, they both end in 5, so let's try 5s. 5 times what is 25? Well, 5 times 5 is 25. 5 times what is 15? Well, 5 times 3 is 15. And again, we automatically know this first one is proportionate. Let's start checking the rest of them. 5 times what is 40? Well, 5 times 8 is 40. Okay. 3 times what is 24? 3 times 8 is 24. And look, they're the same. So I know that they are proportional. Now let's look at the orange. 5 times what is 20? 5 times 4 is 20. 3 times what is 12? Well, 3 times 4 is 12. All right, now the last one. Looking good so far. 5 times 45. Well, 5 times 9 is 45. Okay. 3 times what is 25? 3 times 9 is 20. 3 times 9 is 27, not 25. This is not proportional. Because it's not proportional, they are not similar shapes. Because remember, we have two things that must be true. They must have congruent corresponding angles and proportionate sides. We are missing the proportionate sides, therefore these are not similar shapes. Okay, we have one more example to look at, and this is the last configuration of how things could go right and or wrong. I mean, it's math. Things can always go wrong in new and exciting ways. Regardless, on example G, we are going to start with the exact same two questions. Are the angles congruent? Are the corresponding sides proportional? Okay, so let us look. Triangles again, yay! Biggest triangle, biggest angle, 87. Littlest triangle, biggest angle, 87. Congruent. Biggest triangle, littlest angle, 31. Littlest angle, littlest triangle, they're not congruent. 31 does not equal 32. The angles are not congruent. Because the angles are not congruent, does it matter if the sides are proportional? It doesn't. Even if the sides are proportional, the similars will not, or the shapes will not be similar because the angles aren't. So it doesn't work. Your mathematical ratios will break down. So we don't even need to do the math on this. We can just write naught down here and thank the angles for saving us from doing ratios. That being said, take a look at this, watch through this as many times as you need to. If you need to hear a different explanation, Dr. Khan over at Khan Academy has a different explanation for this. And we say the same things. He just says things a little bit differently. And sometimes you just need to hear it from a different voice. So I would encourage you to go check him out if you're having problems on this. Don't forget, we're doing CIKM tonight. And we're going to go over that in class a little bit tomorrow. And then you're going to have to finish this on your own solo. So I will be available for questions tomorrow before this actually becomes a grade. Regardless, try your best, do what you can. Do not forget to click like, subscribe, hit the notification bell, leave a comment. Let me know what you think. Let me know what you're having a problem on. And I'll see you in class tomorrow.